Okay, so Algebra 1, lesson 5.7 is your last lesson for this semester, and then we review for your midterm, okay? And it is on predicting with a linear model. Okay, so what that is you have data and you're looking to see if a linear model fits it, and then using the linear model that you write, predict what might comes next. So what happens with predicting is we already did the best fit line in, what lesson was that? In lesson 5.4. Okay, so we were already able to say, we looked at data and said, okay, it's linear, and we wrote the best fit, right? You plotted your points, drew the best fit, and then wrote the equation for the best fit. Okay, so in 5.7, once you do that, then you can use the equation that you wrote to maybe predict what happens after, okay? So I have two sets of data. Set 1, here is your XY table. So X is 1, 2, 3, and 4. And then Y would be 12, 25, 36, and 48. So that's our data. And then we have a second set. Same thing. Here's our data. Same X values. And then the Y values are 10, 5, 2, and 1. And we want to look at these data and see which is a line is best fit for. Okay, so to do that, you need to plot your data points. Okay? So I draw my XY axis. And for this, Y goes from 12 to 48. So maybe I count by 10. So here's 10, 20, 30, 40, and 50. And then just by ones on the X. So 1, 2, 3, and 4. Okay, so 1, 12, 2 is 25, so here, 3 is at 36, so just over 35, and 4 is at 48, so almost to 50. Okay, so I have these data points. They look fairly linear, right? Looks like I put a line pretty close to right through those points. Okay, so that looks linear. Let's see if our second data points are linear. Okay, so again, draw your X and Y axis. So we will go by 1 on the x again. So here's 1, 2, 3, and 4. And then we could go by 1 on the y. So 1 all the way up to 10. 2 is at 5. 3 would be 2, and 4 would be 1. So when I look here, they look to have more of a curve. So we would say data set is not linear. Okay? So we can see that from the two scatter plots, set 1 tends to be our linear set. Okay? Then from there, you can write a linear model for this data. So I'm going to look at my line, and I'm going to pick 2 points. So we're going to just use these two. So 1, 12. Okay, so we're going to use the points 1, 12, and 2, 25. So from there, right, you know to write the equation of a line, you're going to find the slope. And slope is change in y over change in x. So it's going to be 25 minus 12 over 2 minus 1. That would be 13 over 1. So your slope is 13. Then you need to write the equation. So we need to find b. So we know y equals mx plus b. So I'm going to use one of our points. Let's use 112. So y is 12 when x is 1. And your slope was 13. So we get 12 equals 13 times 1 plus b. 12 equals 13 plus b. And then solve for b. I'm going to subtract 13. And I get b is negative 1. Now you have your slope and your intercept, so you can write your equation. So we can say y equals 13x minus 1. Okay, we've done that before. Okay, so then after you write your equations, okay, we can say we want to know what happens when x equals 10. Okay, well you have your model, so then all you're going to say is, well, we know y equals 13x minus 1. So when x is 10, we get 13 times 10 minus 1. So we get y equals 129. So we wrote our model, and then we used it to predict what would happen at a later time. Okay? There are two ways to do that. Generally, once you have the equation, you want to just plug in your values and solve, okay? But you can use something called linear interpolation. Or extrapolation. Okay, the interpolation would be, I'm going to go back to my graph, and I'm going to estimate 10 is, out here, so I'm going to look at the graph and I'm going to see where y is, and I'm going to estimate the value. The extrapolation is using left and right of your data point. So usually we want to estimate it by just plugging it in, or using your best fit or your graph to estimate your equations or your values. okay? So that's kind of all we were doing in that last section. Just something to know. It's not a whole lot different than what you did in 5.4, okay? Kind of just a little bit of an extension of that.